So, hello everyone. So, tomorrow there will be a lab. There isn't a lab yet. I'm gonna keep it, relatively compact. How's the assignment going?
The bonus question is impressive.
Nothing's impossible if you believe in yourself.
I gave up,
Okay.
but I might retry
Okay.
and collect myself.
Which file should I submit?
Zip up the whole thing, yeah. The whole C# project. Yeah. Yeah. If it were impossible, there would be no such thing as calculators.
One
Right.
question that's bothering me, Dr. Moore, I think that's hindering my progress on the last question is, do you want, when you press, for example, number 1 on the calculator, do you want the number 1 to appear in the label? Which I don't think it should be a label, I think it should be a text box.
A text box would look nicer, and there's no reason you can't output to the text of a text box the same way that you would output to the text of a label. The only issue is, a text box is also
Change.
read-write, yeah. So, if you'd like to use a text box, I'm sure that there's a read-only property that you can find somewhere in the properties, which I would encourage be clicked. But otherwise, I'm not opposed to the use of a text box for the calculator display. It looks more like a calculator display, absolutely. So,
That's a good tip.
yeah. So, the functionality imagining a calculator with only 3 buttons. So, text is initially blank. On button press 1, we get 1. On button press 2, we get 1, 2. On button press 3, we get 1, 2, 3. Right? So, the number for whatever button that you've pressed is getting appended to the end in each case. Does that make sense? If we are thinking about the text as being a string, then we're talking about a concatenation operation. If we are thinking about this in terms of an integer value, right? Aside from this initial one, which, there's no numeric operation which gets you from empty to 1, because there's no equivalent of empty in integers, right? It's like a null value or something. It's basically if empty, put the button in. If non-empty, multiply this by 10 and then add the new number, right? Multiply this by 10, add the new number, right? So that's what the button keys should do, because that's how a calculator works. Does that make sense?
The difficulty I was having is that in the simple calculator, or the other calculator, the basic calculator, the values are stored, or the values are inputted by the user into the text boxes. But in this case, they're not there. They're contained within the buttons.
Correct.
So that's my difficulty at this moment.
Well, if I may make a couple of recommendations for the implementation of this calculator. Whatever the display is here, it would be wise to hold a variable inside of the class to represent that, so that it can be shared between multiple different buttons without needing to re-fetch the state of the text box each time. Does that make sense?
So it's gonna be if statement, if this button is being pressed, then this action will be happening.
Well, it won't be an if statement, it will be different event methods, right? Each one of these buttons should have its own event method. Within those event methods, you might have if statements. Depends on how you want to design it. But you kind of come to a difficulty when you talk about operations, right? When you press, for example, the plus button, right? Say I wanted to add 3 to this, right? The displayed text doesn't change on a calculator, but when you enter the next button, then the display changes, right? Hello, come in. We're talking about calculators. So then, when you hit the equal sign, then it computes the results of these two summed together and displays it, right? So, the plus operation is storing data inside of the form class, right? You have to keep this somewhere, keep track of it somewhere, right? The obvious choice for this would be to make a new variable and attach it to the class, right? This button, once pressed, needs to also remember what the last operation button that was pressed was, right? So, in theory, you need 3 things. You need a variable for current number. You need a variable for a stored number. And you need a variable to remember last operation, right? Now, the variable to remember last operation, there are various ways you could do this. You could store like the actual symbol for the operation as a string. The way that I usually do this is I just define an integer and then have like 1 mean plus, 2 mean subtraction, 3 mean multiplication, that sort of thing. Make up a little table, 1 means addition, 2 means subtraction, 3 means multiplication, and 4 means division. Something like that. Because then, you can easily write either a switch case or a series of if statements to decide what operation needs to be performed when the equal button is hit, right? So the equal button should read what the state of this variable is, and then perform whichever of these operations was last entered on those two values. That's how a perfect emulation of a calculator would work, or, you know, a slightly more perfect emulation of a calculator would work. I'm not gonna give, if you submit something for the bonus question, I will give you some grades,
Perfect.
yeah. If you, I'm not, it's not an all or nothing.
Okay, that's a good one, thanks.
But, again, the more nicely your calculator works, the more marks it's worth. And for me, nicely is defined like exactly as it should behave. It should behave precisely as a pocket calculator does. The buttons should do the same thing that they do on a pocket calculator. Does that make sense? So, I was wondering if you folks might want to do topic review today, in anticipation of the fact that we only have, like, there's this week and then next week and then exams. And I think it might be helpful to do, you know, more topic review rather than less. So, are you guys, does that sound good? The alternative is to put some time aside to work on assignment 2. But it sounds like many of you have, you know, put significant effort into that one already, so perhaps the time in class can be used more valuably for review. What do you guys think?
What topic you mean? Windows Pro or like?
Anything from the course.
Yeah,
Yeah? You'd like to do review?
yeah, that's a good idea.
What do you think?
Sure.
Okay. So, let's start where any good review session starts and create a mega list of topics that we covered over the course of this course. And we can go through them at our leisure. So, course topics. Number 1, variables. Number 2, let's say assignment statements. If statements. Methods. Using and composing. Loops. Pull in some of the yes, arrays. objects. Objects is kind of a bigger topic, of course. So in objects, we have declaration, / instantiation, we have creating a class, so defining a class. We then have class methods. Class constructors. Class variables. Then we have some of the more conceptual items. We have public versus private. We have composition. We have inheritance. And we have static. After that, we have Windows Forms. And I suppose we should sprinkle in a few Unity topics as well, shouldn't we? Unity topics such as creating and destroying game objects. Mono behavior methods. Working with transforms. / colors. Anything else? Am I missing anything? I think that this is a reasonably comprehensive list. Would you agree? Yeah? So where would you like to start?
From the beginning, maybe?
From the beginning? Okay,
From the.
right from the top, or
From the end.
from the end? So you wanna start from the beginning and work down? You wanna start from the end and work backwards? Okay, we will put it to a vote. How many people want to start at the beginning and move forward through the course? How many people want to start at the end and move backward through the course? Terribly sorry, but I think you've been outvoted. Okay. So, let's review. Well, I mean, you know, any good review should occur in the actual programming environment, right? Thing is, most of these topics I can actually demonstrate to you with Windows Forms or that environment rather than needing Unity, so I think I'm gonna do that just because it's like a shorter startup cycle, you know? Yes, Visual Studio, there we go. It's gonna be another one of these, eh? Again, Microsoft is a scourge upon the planet. There we go. Shouldn't be necessary to force quit your application and then start your application up again in order to get to the bloody load. I'm looking at you, Microsoft. All right, so Visual Studio 2022, let's make a new project. So, just to make this work, I'm going to design a very simple form that we can hook all of our code up to. Just a text box, like a rich text box, and a button that will actually execute the code. So, a rich text box, like so. And a button. There we go. Oh. Two buttons. We only need one. There we go. Properties. Let's call it go. Good. So far, so good? All right. So, I meant this one. All right. Let me just get rid of this. There we go. All right. So, variables. when we declare a variable, what's the first thing that we write down?
The property of the variable, either it's a string or integer
Yes.
or category of.
The data type.
Yeah.
Yes.
Exactly, data.
So what data types do we have?
We have integer, we have string, we have boolean,
Mhm.
and we have float, which is, we can float, double,
Yeah.
and
Hmm?
Alright.
Yes, but we'll review arrays when we are reviewing arrays, if that
I
makes
just
sense.
like, it can include in that.
Yeah, the correct way to think of an array is as a modifier on an existing data type, rather than being a data type itself, right? Because you never have just an array, right? It's always an array of ints, or an array of floats, or an array of object references, right? That's the other type. Object references. So, the way that we declare a variable is data type space variable name optionally initial value. So, things in the square brackets mean optional here. So, for example, int x float y equals 10.4. Yes, with the f after it to indicate that it is a floating point literal. Such an annoying thing about C#. Like, don't get me wrong, I like static data typing, but man. With doubles, that's not necessary. That's actually kind of funny. Make sense? We'll worry about object references when we get to our review of objects. So, from here, this is declaration, of course. From here, we get to expressions. So the assignment statement reassigns the value stored in a variable. It always overwrites the existing contents. So if I were to say x is equal to 5 plus 9, after this point in time, oh, please go away, stupid bloody, hate you. I'm gonna see if I can turn it off. IntelliCode. So, in this operation, I'm computing the value of 5 plus 9 and assigning it to the variable x. We have a full suite of arithmetic and logic operators. Here's a quick rundown of them. Plus is addition. Hyphen is subtraction. Asterisk is multiplication. Forward slash is division. We then have a number of sort of the non-standard ones. We have modulus. What does modulus do again? Yes. Anyone else? What does modulus do? The percent sign?
Like, you mean that one? The value main one?
The percent sign, what operation does it perform?
The divide and the remain?
Yes. That's the remainder of integer division. Remainder of integer division. We also have plus plus and minus minus. What do these do?
Plus add 1,
Adds 1,
and minus is subtract 1.
subtract 1, yeah, very good. We also have plus equals, minus equals, multiplication equals, etc. What do these do?
That's equal as just increment generates everything.
Generates
Is that
everything.
it is add up plus one like it add up?
So if I say x plus equals 5, what does that mean?
They're gonna add up 5 every time?
Not every time.
It's about to reassigns.
Adding x to
What did you say?
Increment the value and then reassign.
Yeah, so close. X equals x plus 5. That's what that translates to,
okay.
right? So it's just take this variable and add 5 to it.
So it's basically saying that x is equal to 5 and then add another 5.
No,
No, okay.
it's taking the existing value of x and adding 5 to it. So if, for example, up here, x was assigned the value of 10, right? Then down here, x would be equal to 15. Right? Does this make sense? So you're close. Now, we don't just have plus equals, although that's definitely the most commonly used of all of these guys. Basically, all of these operations, these 5 operations, you can have equality variants of them that basically, substitute the addition operation for any of the other operations. Does that make sense? Okay, so, good. Let's talk logic operations. We have greater than equals, less than equals, right? These are comparison operators. We also have double equals and exclamation point equals. What does double equals mean? Oh, sorry. I'll hop to the other board. It's like. What does double equals mean?
You just need equal.
What do you mean by equals? What does describe the equals operation? Because it's not the same thing as it means in algebra.
Statement?
Statement? What do you mean?
In a statement, it is like the same. It is like, it's not just variable, it's like it's anything. If it's equal to false, it's just false, something like that. Not sure.
Hmm?
Like both of the variables are equal to each other.
Precisely so. If we are testing x and y, it tests to see if the value of x is the same as the value of y. Yes, precisely and exactly the same. Yes. So we use it in if, we use these guys inside of if conditions primarily. How about with the exclamation point? What does that mean?
Not equal.
Correct. So this will return true if x and y are not the same thing. We also have an exclamation point operator, which is a prefix operator, similarly to turning something negative by using the subtraction sign. What does this do?
Statement's not equal.
Not quite the same as not equals. For example, if I had exclamation point x is less than y,
Opposite?
Boolean inverse. So it turns true to false and false to true. This is actually logically equivalent to x is greater than or equal to y. Right? Does this make sense? Any questions?
Can you explain it once more?
Sure. I'll do it over here. So, for example, if I say not x is less than or equal to y, right? Logically speaking, this is equivalent to saying x is greater than y. Because if x is not less than or equal to it, it must be greater than it, right? Logic. Yes.
So if we write it like this or like that, it's gonna be same thing.
Either of these options will execute. There will be no difference that can be found in your program, depending on what you use. Well, with an asterisk on the end of this, this one performs 2 operations, this one performs 1. Therefore, this is slightly faster, but we don't really care about fast, right? We care about correctness. You can worry about speed once we've got correctness under control, right? So, yeah. So that's the purpose of the not operator. That's what this is called. This is called Boolean not. Well, this is just going to be, it's coming through there. Terrible. What a way to run a railroad. All right. Pure logic operators. Double ampersand and double vertical bar. what does the double ampersand do? What's the
Both.
name?
Both.
Yes, what's the name of the operation though? It's a conjunction.
Concatenation.
Nope, concatenation is something else. Concatenation is this one. That's concatenation. And incidentally, concatenation is overloaded with the addition operator. Right? So, what's this guy?
And
Correct. Boolean and. How about this one?
Or,
Boolean or. Very good. In some languages like Python, they actually just use the words and or. So, if I have x and y, right? If x is true and y is true, what is the value of x and y?
True.
What is the value of x or y?
true.
If x is true and y is false, what is the value of x and y? False. Good.
true,
If x is false and y is true, what is the value of x and y?
false,
Or,
true,
anyway, I know. I need someone else to say what they think the answer is.
it's true,
It is true. And then false is across the board. So I think we need to discuss why this is the case, right? So let's pull out a slightly more complicated example. Let's say our expression we are trying to evaluate, x is less than 5, or x is greater than 10. Right? Let's say that x has a value of 8. Is x less than 5? So that'll be a false. Is x greater than 10? That'll be a false. So the overall calculated result here will be false, right? Which is, like, if you read this, what is this condition trying to calculate? What is the condition it's trying to test?
true, to find a true value, actually true statement.
Think about the number line, right? So we have 0, we have 5, we have 10, 15, -5, etc. Right? This condition wants to test to see if the number that we're testing, x, lies within this red range. Right? If x is less than 5, x being less than 5 will activate for this condition. If x is greater than 10, that activates for this condition. We wish to see does x lie in either of these zones? Right? Not at the moment. But if I made x something like -4, right? This one comes true. This one's false, right? So this range comes out true. This one, no, because the number we're looking for is like right here, right? So the overall result we're going for here, true, right? It is true that this number lies within this range, that as drawn on this number line. Another interesting condition here, because of the way that this condition comes out, it's literally impossible for both of these conditions to be true at once. A number cannot be less than 5 and at the same time greater than 10. That's not how numbers work, right? So, if you could find some magical way of making x less than 5 and greater than 10 at the same time, the result would still be true, but it's not mathematically possible, so we are using an OR operator rather than an AND operator. The AND operator checks the overlap of ranges, right? So if we take a different example, say x is greater than 5 and x is less than 10, right? Take that as a different example. If we draw out our number line, -5, 0, 5, 10, 15, etc., right? X greater than 5 gives us this range here, right? So that's x greater than 5. X less than 10 gives us this range, right? So the AND operation gives us where those two ranges overlap,
Between 5 to 10.
between 5 to 10.
So it could be true.
So in that range, this expression is true. Outside this range, it's false. So that's how you test to see if a number is between two numbers. So as it turns out, this expression is equivalent to the not of this other expression. So it gets a little bit more complicated. If you reverse the operations and change from an and to an or, that is also a demonstrated logical equivalency. This actually is like encoded in logical theorems that go back to the ancient Greeks. I believe this one is called modus ponens. I could be wrong about that. But anyway, it's not necessary to know what the ancient Greeks called it. All you need to have is operational knowledge to be able to program this. So, does that make sense? When producing these types of expressions, especially when you're testing conditions or composing conditional tests, it is useful to think in terms of number lines when you're dealing with integers or floats, and if you're, if you're having difficulty with it, you can also draw out the number line, right? Even in my, somewhat intermediate skill as a programmer, I still always draw out my data structures whenever I'm doing anything complicated, right? I don't need to draw this kind of stuff out because, I've been doing this for a while, but, there's no shame in drawing a diagram. Particularly when you're trying to explain something to someone or, ask someone a question about something. Diagrams can be an extremely helpful way of understanding these types of concepts. Does this make sense? So far, so good? Okay, so, so our discussion of expressions has led us very neatly into a discussion of if conditionals. So, the entire point of an if conditional is to select between two, the whole point of an if conditional is to turn pieces of code on or off, right? I was going to say select between two branches, but does anybody mind if I erase this?
Yeah, that's fine.
Okay, good. So, there we go. So, when we write an if statement, if condition right? The condition, I like to put square braces around things you're supposed to replace when I'm doing like pseudocode examples. There's actually a reason I do this. It's an approximation of of something called Backus-Naur form. Or BNF, which is a meta language used for the definition of programming languages and programming language grammars, but you don't need to know that. There's a reason I'm doing this. It doesn't mean greater than and less than. Anyway, so condition. The condition is composed of these Boolean operations combined with literals or variables. You make these things, you stick them inside of an if statement, basically. So, in concept, what we're doing with an if statement is we are trying to activate and deactivate other sections of code, right? So, for example, perhaps I have a piece of code that I want to activate only when x is greater than 10, right? Maybe 10 is like the maximum value that x should have, or something like that, right? If x is greater than 10, I want to reset it back down to 10. There are actually like real world situations where you would have code like this, right? So, if x is greater than 10, we assign it to 10, right? This caps it at any time that code is executed, right? So, this branch executes if condition is true. This one, if condition is false. Right? This if true, this if false. Make sense? Now, things become, things start simple and become more complicated as usual. Do you have a question?
No, I was just,
You're just doing it in your brain?
yes.
Yeah, good. If you'd like me to expand on anything at all, literally just stop me and ask me a question, because that is the whole point of this. I'm a teacher. I can ramble on for literally days. So you gotta stop me. The only thing that stops me is the bell or a question, okay? You may have noticed this about me, is I have the gift of gab. So this is your basic if-else statement. If expressions do not require else cases, so this guy is optional, right? Without this, you're not writing an if statement, right? You're just writing an assignment statement. Now, the next step from here is the if-else branch. So if we have if condition 1, else if condition 2, else if condition 3, else. You can have as many of these as you want, right? If C1, right, is true, then you activate the first branch. If not C1 and C2
It's true.
is true. Right? So the thing about an if-else statement like this, whichever the first condition which tests as true is, that's the branch you execute, and you execute no other branches. Right? So if C1 is tested and is true, we ignore the other 3 branches. If C1 is false, then we test the next condition. So, as a result of this branch will only execute if C1 has already been tested and has come out false. Right? So C1 must be false here. But to activate this branch, C2 must be true. Right? So, in this branch, right, C1 must be false, C2 must be true. Here, I'm getting a little carried away of using too many math symbols. Let me rewrite it. C1 is false and C2 is true. Make sense? For this condition, the same thing applies. Condition 2 must have already been tested, right? So C2 has been tested, C1 has been tested, both of those came out false, right? This branch gets executed if both of these were false and C3 is true. So, if C1 is false and C2 is false and C3 is true. Make sense? And then finally, the else case catches if no other branch, if none of the other branches were executed, then the else case is executed. If C1, C2, and C3 are all false. So, on the face of it, the difficult part about if statements is not if statements themselves, it's the conditions that you put in them, right? But things get more complicated when we realize anywhere I've put a comment here, you can put any amount of code and any number of other different types of statements. So inside of this guy, I might have bubble sort, right? For example, maybe condition 1 is something like sort is bubble sort, then this one would be the bubble sort algorithm. If sort is insertion sort, then like if C2 is this sort, the sort I want you to do is insertion sort, then this would be the insertion sort algorithm. You know, if this C3 is the sort I wish you to do is merge sort, this would be the merge sort algorithm. And otherwise, we would default to, I don't know, quick sort or something, right? So these can select between quite large things. Now, if the algorithm is large enough, right, what you actually want to do is you want to define a method for it and call that method inside of the if branch, rather than just plunking the whole thing down each time, right? But, you know, we haven't talked about methods just yet. So, are there any questions about if statements? No? Everybody understands them well? You've been using them all semester, so. Perhaps a few brief notes on the equivalency between, or like, yes, perhaps a few brief notes on how switch statements work. Switch statements review, you wanna see that? Yeah. So switch statements are a special type of if-else case. They work, basically an if-else case is replaceable with an if statement if the conditions are of a particular form. Something like x is equal to, you know, constant 1, x is equal to constant 2, x is equal to constant 3, right? It requires that equality is being checked at each point, right? And instead of true, like we're testing to see if it's x, right? Etc. You get the idea. In this case, we can translate this whole thing into a switch statement. Switch statements are a bit more compact. They're a bit more flexible in some ways and not as flexible in other words. It's, you know, they're a good thing to know about. Switch x. So we specify what the variable is that we are comparing in each case. Case C1. Case C2. Case C3. And instead of else, we have default. aside from, aside from the different structure and the far fewer number of curly braces, you see that there is an exact correspondence between these if cases and the cases in a switch case, right? Now, even the way that it executes is exactly the same. The switch case goes through each of these cases in the order they appear, goes to the first branch that comes out true, executes that, and then the break breaks you down to the end. Basically what break does, it's a command that means get out of this structure, right? So the break gets out of the switch case and, you know, your code continues after that. Incidentally, that's why if you leave a break statement out, if you evaluate x as C2, it will execute this code, keep going, execute this code, then hit the break, then exit. That's why the breaks are there. You might think to yourself, why is it necessary to write break each time? Couldn't they just built that in? But no, it actually does have a purpose. This is actually a form of contained go-to statement, but go-to statements are, they are elder magic. We no longer deal in the old magics. Go-to statements are considered a very, very bad thing to use in coding, basically because unless you're very careful with them, you can very easily write programs that are impossible for other people to read. And I know it's like, you know, perhaps you think that most programs are impossible to read, but with go-to statements it's even worse. We have a condition, or I guess you could say a pejorative term in coding. We call code spaghetti code when too many of these types of go-to constructs are used. Basically the problem here, right, the problem is not present in a switch case because everything is neatly and clearly defined. You have your defined entry and exit points. You have the way that things jump around inside is well defined. Everything is nicely structured. It's not a problem. The problem is if you are able to use general go-tos, you can do all kinds of nasty things like jump to the middle of functions that you haven't actually called, right? So basically, you know, what happens is you start a line of execution, it goes off over here, then you have two more that go off here, comes over here, that one goes over here, jumps back, jumps back, jumps back, down, down, one round, you know, 3, 4. You see how things are kind of beginning to look like a ball of yarn, right? This is what you call spaghetti code, and this is your tendency if you are allowed access to go-to statements, particularly if you are an inexperienced programmer. So, go-to statements are forbidden. They are forbidden. Most modern languages do not even contain them. That's how bad they are. However, there are a couple of languages where they still exist, that are still used, most notably C and C++. Yes?
So for our simple calculator, we can use the switch method.
Yes. When selecting which operation you wish to perform, either of these are fine, but, well, now that I'm thinking about it, simple calculator would not use this, right? With simple calculator, each one of the operation buttons will trigger its own event method, right?
Yeah.
So there'll be no need to use this.
Yeah, okay.
Yeah. In the pocket calculator though, you will need something like this. Because X in that case will be, what was the operation button last hit before you hit the equal sign? And then you will do, addition, subtraction, multiplication, and division. Right? Make sense? Any other questions? Okay, good. I'm going to call that if statements complete. All right. Moving swiftly on, let's talk about methods. I thought I was going to do more stuff on the board, or more stuff on the computer, but I think the board is doing fine. Yeah? It's a bit faster as well. Okay. Are you okay if I erase this board over here? I should have put this over here or something. All right, let's continue speed running intro programming. Okay, so. Do I want to cover loops next instead? Yeah, I think that makes more sense, doesn't it? We kind of covered it like in a slightly wrong order, just because that's how Unity works. Normally loops are covered immediately after if statements. Yeah. So we're going to do loops first, then we'll come back to methods. So, what does a loop do? If an if statement selects between different branches of code, what does a loop do?
Continue the same process until it has a result.
Yes, sort of. So the word I'm looking for here is that it repeats a branch of code until some condition fails or is met. Some kind of Boolean condition must happen. But the purpose of a loop is to repeat the contents of the loop. So, the most elementary form of loop is, what's the most basic form of loop? Okay, who can name a type of loop?
For loop?
For loops are a thing,
Oh, sorry.
while loops are a thing,
For each loop, for each loop.
for each is also a type of loop, and there's one
While loop.
do while, yeah. Do while, do while, do while, do while. So, of these, the while loop is the most basic form of loop. The while loop goes like this. While condition code. Right? So the semantics here. So long as this condition is true, this code will be repeated. The condition is checked at the end or at the beginning before this piece of code is executed every time it's executed. Right? So the while loop, operationally, first you test condition, then execute code. Right? So long as that condition is true, you execute the code. If during the condition test, okay, let me just rephrase this slightly. If the condition comes out true, you execute the code. If it comes out false, you exit the loop. Make sense? So when we enter the while loop, right, we test the condition. If that condition is true, we execute the code inside the loop. Once we've finished executing the code inside the loop, we automatically test the condition again. And you can get stuck in there, that's where the loop is, right? If this condition, once tested, comes out false, you break out of that and you exit the loop, and then you execute whatever comes after the loop. Does this make sense? Hopefully. Any questions? So, one of the consequences of this type of structure, if your condition is not ever true, it is not ever false, right? You are literally stuck here for infinity cycles, right? Sometimes you want this, but most of the time you don't. The easiest way to set this up is to say condition 1 is equal to true, like the truth literal. The truth literal can never be false, so that is, if you put true in here, that's just an infinite loop, right? Infinite loops are a very common source of bugs in programs. They are actually one of the more common sources of fatal bugs in programs. An infinite loop will crash your program. What happens is the program will appear to hang. It will just stop responding to inputs, it will stop doing anything, right? And the reason is, your program executes one statement at a time. If the only if statements it's executing are these ones here, it's never executing the rest of your program. The rest of your program is taking inputs from the user, displaying things to the screen, etc., etc. Now, it is possible to escape from an infinite loop if you use a break statement correctly. Break statements will also break you out of loops. But, the structures that set up a break for an infinite loop, like there are definitely use cases, but most of the time, if you find yourself using a break statement to exit out of an infinite loop, you should probably just make whatever condition was on that break statement the condition for your loop. Because you don't unconditionally break from a loop, because otherwise there's no point in writing a loop in the first place, right? I have a joke. I have to show you a joke now. I may have already shown you this joke, but. Can you read this? Maybe I blow it up a little bit more. Copy and open. Where's image? Save image as. Save. Open. Bigger. Lovely. Mom, can we get an if statement? If statement. No, we have an if statement at home. The if statement at home. So the joke is that, like, if you have a while statement, right, and you just execute something and then break at the end, literally, it's just an if statement, right? So this is a joke because that's a terrible, like, you can do this, but why? It's terrible, but it's possible, right? It works, but, you know, you're definitely, you know, riding around on your sister's bicycle, let's just put it that way. But it's a pretty good demonstration of like how while loop semantics work, right? So in this case, if condition statement 1, else statement 2, right? So we've got while condition, while not condition. So that's your true case, that's your false case, right? The loop will not be entered if the condition is initially false, right? You'll just skip the contents if the loop condition is initially false. So if this is not true, it'll just skip this and then pick this up and execute this. So statement 2 will be executed. In both of these loops, if you reach the end of the loop, you hit a break statement which exits the loop, defeating the purpose of the loop in the first place, right? Right? Because if you're breaking without like anything protecting you from that break statement, that just breaks the loop. So it's like it executes once and then it breaks and that's it, right? So yeah, this behaves exactly the same as an if statement would, but you know, you wouldn't do this in practice. I think the child is right. The mother should buy an if statement. So, yeah. There we go. So, okay. So do while then. The do while loop follows a similar procedure to the while loop, except that the code is tested, the condition is tested at the end, not the beginning. So, in this case, you come in, you execute code, then you test condition, if that is false, then you exit loop. And if it's true, you re-execute the code. So, as stated on previous times that we've gone through the difference between these two bad boys, this guy will execute the code 0 or more times. This guy will execute the code 1 or more times. Ultimately, you can get these things to do anything you want if you're sufficiently skilled, but this is sort of as they were designed. This is how they're used. Make sense? Shall we talk about the for loop then?
So the do while loop will execute 1 time or more, right?
1 or more times, yes. So if you think about the flow, right? Here, the first thing we hit is executing the code, so that gets executed. Then we test the condition. If the condition is initially false, we exit after having executed the code once. So code execution count is 1. On this guy, if the condition is initially false, we come in, test the condition, it comes out false, we exit the loop,
The code never executes.
the code never executed. It executes 0 times. It's skipped entirely. Does this make sense? So far so good? Shall we talk about the for loop then? Sorry, did you have a question?
I said yes.
Okay, yes. For loops. I'm going to leave the for each loop until we've talked about arrays because it doesn't really make sense outside the context of the array. So, for a loop. So, the for loop, as we've known them so far, right? In general, something of the form int x equals 0, x is less than 10, x plus plus, right? In actual reality, this first one is an initialization statement. The second one is the condition that you're testing. And the third one is the update. This is how, so basically, the for loop is a while loop with a few extended bells and whistles. A few things that it does in addition, which are often forgotten by programmers, resulting in infinite loops. So, this is how a for loop works. First, we run the initializer. Next, we test the condition. If the condition comes out true, we then execute code. Then we run the update. Then we return to the initial condition. If false, we exit loop. So, the for loop is really identical with the while loop. The only difference is we have this initializer, which is always executed before the loop is created, or not before the loop is created. It's executed before the condition is tested the first time it's tested, and we have an update which is always executed after the body of the code is executed, the body of the code in the loop is executed. So the reason that we prefer for loops is that they are safer than while loops. The reason that they're safer, to write a for loop, you must write an initializer, the condition, and the update. If you're just using a while loop, you may forget this one, critically, this one. If you forget the update, you will end up in an infinite loop most of the time. So, basically, because this thing won't even compile if you forget it, right? This is the programming language saying, hey, you need to update that. If you update that, you're gonna make me sad by making me try to execute an infinite loop, you stupid human. So, because the for loop syntactically requires the update, it is safer to use it because it means that you, in your poor human fallibility, are less likely to forget to do the thing that you need to do to not end up in the infinite loop. Does that make sense? This is why this is the one we use most of the time. Now, both of these structures are somewhat flexible. You actually don't have to use a for loop in like this form for counting. For loops are very good for counting. There's really no reason to use a while loop over a for loop if all you're doing is generating a series of numbers, right? Where while loops are really good is where the condition is like non-numeric or strange in some way. Here, I can show you an example. I'm going to make some additional form stuff. Just a text box, a button, and an output label. There we go. Say banana. So, this isn't gonna work. Man, it needs to be in a console application. Okay, it's not gonna work in this event-driven structure. Okay, so, all right, we'll leave that example. The example that I wanted to show you that I'm in the wrong environment to show you is like most programming languages have a command for taking input from the user. So you could write a program that requires someone to say the word banana, right? Because basically what you would do, right, inside of your loop, you would put the code that asks for user input, and your condition would be while user input is not banana. So actually a do while loop would be better for that because you have to get the user input at least once. So, you know, it's like, say something. Okay, potato. You know, potato is not banana. Goes back up. Say banana. Okay, strawberry. Nope. Strawberry is not banana. Goes back up. Say banana. Okay, banana. It's like, okay, thank you for saying banana, and then it'll go on, right? So that is, like, these conditions do not have to be numeric, right? Numeric conditions are best served by for loops. Non-numeric conditions are best served by while loops. But you can see that, like, that while loop will, like, the user is in complete control of how long it takes them to give up and say banana, right? So, yeah, basically. Does that make sense? All right. Shall we call loops done then? Any questions about loops? Can I erase this board? So, methods, aka functions. Lots of other languages will call methods functions, such as the JavaScript and PHP that you will be studying with me next semester if you pass. No, you'll, I'm sure everyone's gonna pass. We'll see. Anyway, I want to leave the I want to leave the option open because it's good motivation. Study or you will fail. Yes. Anyway, so methods. Since we have talked about these 4 topics, this is a very famous theoretical result in the mathematics of computer programming languages. With these four categories studied, we can write any program. Literally all programs can be written as variables, if statements, loops, and various arithmetic expressions. Now, it's nice to have other stuff too. So we don't stop there, right? Basically, everything past this point in the course is nicer and nicer ways to organize these 4 topics, which are the core topics. Right? Does this make sense? So we come to methods, or functions. The purpose of a method or function is to take a series of statements, a series of this stuff, package it up so that it can be called multiple times in other places. This is the purpose of the function, right? Think about it in terms of, algebra, right? The purpose of the function in algebra, right? If I have a parabola in regular math, we define that parabola using a mathematical function, right? F of x is equal to ax squared plus bx plus c for some constants a, b, and c, right? So far, so high school? The idea of the function is I provide an input, and this is the method by which we calculate an output, right? So, we might say, sometimes you don't say f of x, sometimes you say, y, right? Put another variable in there. But the point is that this is a procedure. We've got an input, which is x, and we calculate an output, which is y. This is the model on which the method or function is based in programming. We are trying to recreate this as closely as possible. So, goodness. I'm getting too excited about math. So, let's, these aren't going to be the correct constants for this parabola, because I can't do that in my head, but let's say that f at x is equal to 5x squared plus 7x minus 10. A parabola defined, right? If we wanted to write a method in C# to compute that formula, we do it as follows. First, we have to decide what the inputs and the outputs are. Now or what their data types are, right? For this type of mathematics, we generally default to real numbers, right? Remember my discussion about how the natural numbers are a subset of the integers, which are a subset of the real numbers, right? This is where math defaults to most of the time. At least, that's why it's called real. Those are the real numbers, right? It's not that these are fake numbers, these are the natural numbers because we teach them to small children, right? Anyway, so the data type associated with real numbers in real mathematics is which? It's float or double, right?
Oh.
Integers are
For
integers, yes.
Yeah,
So this is float, so we will want a float going in and a float coming out. So the return type will be float. This is the difference between, one of the differences between functions as defined in algebra and functions as defined in computer programming. Here, we are basically assuming everything is of this type, right? But in computer programming, we have to say that explicitly. At least in any good language that's worth using. Some languages, they don't require you to do this, but that just causes more problems in the long run, in my personal opinion. So, we define the method float f accepts argument float x. Now, in general, we will make this either a private or a public method. That's kind of an object-oriented concern, so let's leave that for object-oriented programming. Let's just concern ourselves with methods, right? So, we then calculate y is equal to 5 times x times x, y plus equals 7 times x, and y plus equals negative 10, or although I suppose you could do negative minus. It doesn't matter, right? Logical equivalent. This calculates this formula term by term. Right? Make sense? It accumulates the result in a variable y, which I actually didn't declare.
Yeah.
There, it's declared. Indentation. Terrible. Anyway, it's on the board. It's a review. Anyway. So, the next thing that we have to do, and this is a critical thing with computer programming, the computer does not know that y is intended to be the output. right? Because computers are stupid, they don't know anything. They only know how to calculate, right? Even such things as ChatGPT does not know anything. It only knows how to predict what the next likely word in a sentence is, right? The next most likely word in a sentence. That's all it's doing, right? It's not God. It's not a hyper intelligence. It's basically fancy autocomplete, right? Anyway, so because computers are stupid and don't know anything, it doesn't recognize that this variable is intended as an output variable. Even if you call it output, it doesn't know that, right? So, because this could be one of 50 other variables that you defined in this method. It doesn't know that, right? So, it needs you to explicitly say, this is what I am kicking out. This is my output. And the way that you do that is with the return statement. The return statement stops execution of the method immediately, so it, pardon me, the return statement operates similarly to the break statement in a loop. It will just end the thing completely right there, stop it dead, you're done. Return, you're done. It then passes the return value to whatever called the method, right? So you have to think of this in terms of substitutions, right? If I have a, say this is being called in, z is equal to f at 10, right? This is how you would use that method. When the computer execution hits this statement, it says, okay, I need to calculate the value of f at 10. So then it starts this procedure, runs through all of this code, takes whatever the return value is that's returned. I'm not going to do the math, so I'm just going to say it's 7. And it substitutes in the calling expression the value that was returned. It clicks it in. Substitution. Right? Then it proceeds with the rest of the calculation. So that's how it's used. Does this make sense? Good. Okay. Normally we don't get out of this classroom soon enough for the class that's coming in. So I'd like to be nice to them this week. So all right, let's go. Let's roll. Let's hit the road. I'd like to be a more cognizant citizen of the college. All right.